TCP, UDP, what do we really mean by that when we talk about it as IT professionals? Find out more next.
You're watching IT Pro TV.
Ports and protocols, there are plenty of them for us to dive into, and Wes Bryan is going to help us to understand this. All right, Wes, there's plenty of these things here. What are we actually going to be taking a look at today?
So we're going to help our viewers out there to identify some of the most common ports and protocols that we use inside of network communications today, because if you're in a certification endeavor, they might test you on this. And if you're in a support endeavor, you're going to be configuring these in the field, then it is going to be important to know what these protocols are and know the ports that are associated with them when you're configuring them.
All right, sounds like it's time to head over to the bench.
All right, everyone, go ahead and follow me. I've got my computer set up here, and we've got a series of protocols that we need to talk about. Now, before we actually get into looking at the various ports and protocols, we kind of define, well, what is a protocol and what is a port? All right, well, a protocol is a set of rules for a specific type of communication between two endpoints, right? So when I need to, let's say, make a communication with a type of server out there, and I need a resource, we're going to use a certain protocol, a structured set of rules for that type of communication in order to provide and get access to that service. Now, it is also important to understand that when we talk about ports, ports are an identifier. They're a logical endpoint of a connection, if you will. And when I'm going to send a request out over a network for a certain service that the protocol provides, I'm going to send it to a device that's listening, typically a server, and that server's listening out and it's saying, all right, I see that incoming port. I can identify with a service that's being requested here, and I am that server, and I can respond back to you. Now, when it comes to ports, we have to understand that there are a certain set of ports that you have to be able to identify. And the first ones that we call are what are known as just port ranges, right? The first one being something known as the well-known ports. So what are the well-known ports? Well, understand the well-known ports, these are the common services. These are the common protocols that we use within our networks today. And that's why they're called well-known. They're easily identified, and most computing systems will recognize these protocols. Now, that range, if you will, is from 0 to 1023. Be able to identify that if you're on a certification exam, but it's also important to understand that if you are supporting these protocols, you need to know that the well-known protocols fall within those ranges.
Yeah, it's kind of neat here that the very fact is, as data is going across, most applications that we see, they tend to assign themselves their own port numbers, and then they get registered or recognized across the internet as using that, and it just becomes familiar so that you don't have to guess what it's going to be when you actually know something is coming in on that particular port number as well.
Definitely. And the communications for networking that were standard, these protocols that were standardized, a lot of those early protocols and the major ones that we use fall within that range. But that's not the only range that we have, right? In totality, we have 65,535 protocols, 0 being included, so technically 65,536. The next port range is going to be what's known as the register port range. Now, the register port range a lot of times is where organizations have a specific piece of software and they set aside and register a port, if you will, within this range. So for instance, Microsoft has something known that we'll look at a little bit called RDP, right? That's port 3389. It fits right in there in the register port range. I want you to be able to know the register port range. All right, because the register port range starts at that 1024 and goes all the way up to 49151. That is your register port range. Now, the last range that we have, the upper end of that range, is actually what's known as dynamic ports, right? The dynamic ports are the ones that your computers, when they request a service via that protocol and they send it out with a port number to the server that's listening out, well, the server has to respond back. So your computers will dynamically generate these temporary ports that are in that 49,152 all the way up to 65,535. And these will be used for communications, but then once that communication's done, your computer will generate other dynamic ports for outbound communications as well. So that is the dynamic port range. All right, the dynamic port range, again, 49,152, all the way up to 65,535. These are your port ranges, and a little history behind that real quick. Remember that the internet Internet Assigned Numbering Authority, INA, if I can get the acronym right. They're the ones that actually set this up in the earlier days of networking, and it is the body, if you will, that largely has dictated what these port ranges are.
Now, we had mentioned during our opening that we'd be talking about the idea of TCP and UDP. There's a lot of confusion on this as you read across the internet because they also associate things like what they say connectionless protocols and connection-oriented protocols. Help us out with that.
Oh, absolutely, Ronnie. So when we talk about certain protocols, right, some protocols can be connection oriented, and what that means really is that they provide reliable delivery, right, and error checking. And if the information isn't received in the right order, then that information is going to be dropped, and the connection oriented protocol will call back to the source and say, hey, I need you to resend this information. We didn't get it right. That is what is known as transmission control protocol based ports. That's kind of having like delivery confirmation on your mail, right? You send your mail over snail mail, if you will, across the postal carrier service, if you will. And what happens is, well, the envelope is going to be marked, and then you are going to get a confirmation that yes, it was received at the other end. That's transmission control protocol. Now, there are times when maybe speed is of the essence, and you don't need the complexities of checking every single piece of information that's going to the endpoint and saying, hey, I received it, or hey, I didn't receive it, but you need fast delivery. Well, that's where we talk about connectionless services, and that's User Datagram Protocol, UDP. It is what we call best effort delivery. That's like putting your mail in the mailbox and walking away from it, and you just hope it gets there, right? We're not actually checking on that. Now, again, there are purposes for these different types of communications. Transmission Control Protocol provides you that reliable delivery when you cannot afford to have data corruption. UDP says, let's give you the fastest service, and if you need any kind of connection-oriented service, well, the application itself is going to have to actually provide that. So those are the differences, right? One, reliable delivery. One is a best effort delivery.
Now, when it comes to that, the neat thing about it is most of the things that we tend to see that go across the internet are really not based on UDP, but really based on TCP. That idea, that connection-oriented protocol to ensure across the entire networks, right, that the stuff gets there exactly the way that it's supposed to. So, Wes, with understanding that, what are some of the different protocols that we need to learn about?
Yeah, Ronnie, probably the life's blood of a lot of organizations are protocols surrounding email, right? It's our communication system. It's how we communicate with the outside world, if you will. And one of the things that I would be aware of these email protocols are the types that you have and the port values, port numbers that are associated with them. Though there's three that we have to worry about. So, for instance, if I'm in my email server here, or I'm in my Gmail, I should say, that we have created for these for these demonstrations, and if I choose settings, you can actually see some indication of these various protocols here. So, you see all settings here inside of Gmail, and I want you to notice that we have this forwarding and this POP and IMAP. Right? These are the settings for some of the email protocols that you might see. All right. If we're talking about something like the Post Office Protocol version 3, that is for receiving email. Receiving email over what is known as port number 110. Now, interestingly enough, when we talk about the Post Office Protocol version 3, POP 3, when we download email via that protocol, that email is going to be wiped from the server. All right, so it is important to understand that. Now, the other email protocol that we have, and it's been around for a long time, is what's known as the Simple Mail Transfer Protocol. This is SMTP. Now, SMTP allows you the ability to send outbound email over port 25. The more common one that we see today is the one that is in this list right here if I want to enable something like IMAP. IMAP is the Internet Message Access Protocol. And what's great about this is this gives me the ability to look and view my emails just like they were local, but I can work with them up on the web server, right? So this is another common email protocol, and that is port 143. Be able to recognize the purpose of these protocols as well as the port values associated with them.
All right, there's no doubt that email actually is going to be one of the most important things that we do have to know about, but we also need to actually think about, well, web protocols. Help us out with that.
Sure. Web protocol is another very common protocol that is out there, providing us the ability to connect to web servers and render HTML pages locally. There is a protocol that's been around for a long time that has allowed us to do that, and that's HTTP. That's the Hypertext Transport Protocol. And that goes over port 80. However, it has been discouraged from being used because of the security vulnerabilities around it and people being able to gain unauthorized access to the communications between your browser and the web server, which is why we use protocols like, for instance, this right here. So I'm on ACI Learning's webpage, and one of the things you're going to notice is that I have this little lock right here. Well, what does the lock represent? That lets me know that currently we are using HTTPS. If you can see it right there in the URL, that is the Hypertext Transport Layer. And in earlier days, it would be over Secure Socket Layer. Today, it's just, think of it as HTTP Secure. And what it does is it provides something known as a TLS encryption mechanism that, for you, I want you to remember, keeps unauthorized, or the goal is to keep unauthorized access out of your communications between the web server and your browser. These are two important protocols: port 80 for HTTP, port 443 for HTTPS.
Yeah, actually, you make a good point here, especially about the idea of security, and something that you should know as an A+ technician moving forward, that when somebody does connect to a website across the internet, they probably should never actually connect to one that only is serving up HTTP, because you can never really verify the identity of that particular server that you're connecting to. With HTTPS, though, you can actually get that verification that you are connecting to the right server. All right, now Wes, now that we actually understand more about the idea of email and, of course, the web protocols that we have to be familiar with, what about file protocols? What are we mentioning there?
Sure. File protocols are another one that are really big, and there are one really that we use a lot that's been around for a very long time. And what I'm talking about is something known as FTP. That's the File Transfer Protocol. This goes back to the earliest days of the internet, so it's been around for a very long time. And FTP actually uses two ports. It uses port 20, if you will, for what are known as control and command ports. Let me show you what I mean. So I can drop down to a command prompt, and if I want, I could issue some commands out to the FTP server. Maybe put a file up there, pull a file down, if you will. Well, that right there, those commands go over port 20. However, when I connect and I access the resources, the data is coming over port 21. Now, one of the great things about FTP is that at being an application type protocol is that it works with web browsers. I could drop to the command prompt if I want, and I can issue commands against an FTP server, and that's going all the way back to the earlier days when there weren't any graphical user interfaces. But FTP also allows you the ability to connect via a graphical user interface. So for instance, University of South Florida has their FTP server out there, and if I click it, one of the things that you're going to see here is that I have access to their file structure, and this is in our File Explorer. So even though I'm connecting to an FTP server over the public internet, you'll notice that I actually have ftp.usf.edu. We're using the File Transfer Protocol. I also want you to know that the File Transfer Protocol, FTP, uses that connection-oriented protocol that Ronnie was mentioning in TCP. Now, it has the complexities. It's highly optimized for large file transfer, but it uses transmission control protocol. And sometimes you need to deliver small files and you need speed versus all of the complexities of that connection-oriented service. And that's where another protocol comes in, and that's known as Trivial File Transfer Protocol. It is a stripped down, you consider it as FTP light, right? It strips all the complexities of TCP and it uses essentially UDP. That is another port, Trivial File Transfer Protocol, that doesn't have all of the command structure that FTP does, but it does allow you to download a small files, really optimized, and it uses the user datagram protocol. Now that is going to be over port 69, if you will. So FTP ports 20 and 21, Trivial File Transfer Protocol, TFTP, this is going to be port 69.
All right, there's also, of course, our ability to be able to use these ports to connect to remote machines, right?
There are. And in the earlier days, we would drop down to, and again, like FTP, going all the way back to some of the earlier days of the internet, what we would use to connect to things like mainframes from a terminal is a terminal emulation software, something like Telnet, which is just telenetworking, if you will. Now, This protocol is, again, it allows you to make connections and test if ports are open, which is really nice. It does use port 23, but it's one of those protocols that, again, if you have, it has security issues, because when you're issuing these commands, there's no security around them. And again, if somebody could potentially gain unauthorized access. That's why we use other types of ports today. And by the way, let me go ahead and mention port 23 for Telnet, but we also use things like SSH. SSH is the secure shell, and what that does is it creates an encrypted communication, a secure communication between source and destination, and then the commands that flow through that encrypted communication allow for the protection from unauthorized access. SSH, or secure shell, uses port 22. Now, that's not the only remote connection-based protocols. It's probably one of the most common in your Linux environments, and in some of your Linux servers, you're going to be using something like SSH. However, if you're in a Windows world, you can be using something like potentially remote desktop protocol. So for instance, I'm on my server here. Maybe I decide that I want to make a connection over a remote desktop connection using something known as the remote desktop protocol. Well, I can fire up a piece of software like Microsoft's remote desktop connection, and what I could do is I could put the computer name in here and I could choose connect. And notice that what I'm doing here essentially is connecting to this machine over the network via the remote desktop protocol, and that's port 3389. And this allows me to remotely control the desktop of another machine. So I'm on server 02, and what I did is I'm connecting over the network back into another computer, making a remote connection via remote desktop protocol via port 3389. And now you can see that if I look, I'm now on my domain controller, right? I'm no longer on that server 02, and I can manage and control the desktop. So remember those ports as well. Telnet, security issues, port 23, secure shell is what you should be using. SSH to connect to these machines remotely if you're not in a Windows environment. If you're in a Windows environment, you're going to use RDP. SSH port 22, RDP port 3389.
Now, there's also, of course, a bunch of different protocols that we're going to have to just be familiar with and learn. But learning them now will actually help as we actually go ahead and advance our career through our IT career, which are going to be networking services, right?
Definitely, Ronnie. And I'm going to go ahead and what I'd like to talk about, since we're already mentioning, I connected to the domain controller. So let's take some of the technical jargon off of that, right? A domain controller is a directory services server within an Active Directory domain. It's not the only directory services out there, but it's one of the most popular in the world, in the enterprise level market. And it's using something known as LDAP, right? LDAP is the Lightweight Directory Access Protocol. Now, it uses other protocols, but it also uses LDAP. The Lightweight Directory Access Protocol, when I need to connect to a directory services database and communicate with it, send queries against it to retrieve information, it's going to be over that port 389. If you're in a certification endeavor, exam alert on this one. Do not confuse LDAP and RDP, because LDAP, Lightweight Directory Access Protocol, is port 389. RDP is port 3389. And we can see that if I'm running something like Active Directory Directory Services, that's essentially going to be my LDAP server. Now, there are other things that we have to take into consideration too. One of the networking services that we use so much today is what's known as DNS. All right, well, the DNS service, when you are communicating via the DNS protocol, you are going to communicate over port 53. So when I need to do name resolution and map that fully qualified domain name to its IP address, and I make a request to that DNS server to find that IP address, it's listening out on port 53 for those incoming requests. So DNS port 53. Now, that's not the only thing we have too. Let me go ahead, and what I'd like to do is hop back on over to my DHCP server, and we'll look at DHCP. Now, DHCP is another service, a protocol, it's a service, it's a protocol that's associated with a service, if you will. And the Dynamic Host Configuration Protocol, allowing us to dynamically assign IP addresses, that goes over port 68 and port 67. There are other network services that are out there. I mentioned DNS. In a Windows domain or in a Windows world, you also have an older naming convention or an old name resolution service, and that's called NetBIOS. And NetBIOS goes over port 137 and 139. This is an earlier, non-scalable, non-routable, legacy-type naming resolution service in a Windows environment. So know that NetBIOS, about NetBIOS, port 137 and port 139. Now, moving down the line, we also have some protocols that allow us to share resources within a Windows environment. So if I go ahead and I open up our File Explorer here on Server 01, I can actually connect back to administrative shares, if you will, that are on my domain controller. Notice that we made a connection here, Ronnie. All right, I'm using a UNC path, the Universal Naming Convention. Oops, try that again. There we go. And what I did is I connected over the network, and as I connect over the network, it's using something known as server message block inside of a Windows environment, not only to share files, but to share any resources, a folder, if you will, share printers out there. We use the server message block. All right, ladies and gentlemen, that is going to be port 445. And last but not least, a very important network service that as you move into your careers, you're going to probably work with a lot more is something known as the Simple Network Management Protocol, SNMP. SNMP is a protocol that allows you to track the health of your connectivity devices, variety of networking devices on your network, that they can send information back over the network to a management station. You can figure out how they doing. Are they healthy? How long have they been online? Are they having any issues? There are two ports for that one that I want you to be aware of. That's port 161 and port 162. Ladies and gentlemen, if you're in certification endeavors, I would know these ports and be able to identify the port and protocol associations. And if you are in a support role, you should be able to do that as well, because a time might come where you have to sit down and you have to configure one of these protocols. To do it correctly, you have to know the associated port values.
Thank you for watching IT Pro TV.
Networking components really look similar. Well, how do you differentiate them? Find out more next.
You're watching IT Pro TV.
Over on the bench right now, I see a bunch of rectangles and some things that actually look like antennas. But Wes, what we also have to do, of course, is be able to kind of compare and contrast them, right?
That's right. You know, as in your certification endeavors or in support endeavors, when it comes to the networking technologies, it's important to be able to identify and explain the purpose of these devices so that you can have that conversation should you be sitting on the IT staff. So that's what we're going to look at today, a variety of the most common networking devices and what is their purpose? You know, what are they actually doing for us within networks today?
All right, I see a mountain of hardware over there. Let's go ahead and get started.
All right, everyone, join us at the bench here. And Ronnie is right. Don't worry, Ronnie's credit isn't bad. I didn't buy all this equipment here. But we have a variety of networking equipment. And one of the first things that we're going to do, you know, I put these together in a way that I believe will help you to see how are they chained together, right? Because when we talk about networking devices, networking components, we have a variety of them. And the first component that is typically in that chain, if we take a close-up view, is going to be one of these. And that is something known as our network interface card. Now, if we stay on that close-up view, I want you to understand that that's a dedicated adapter that you could replace in a machine. But I also want you to take a look at that back I/O panel over here, too. There's also embedded network adapters or network interface cards, NICs as they're called. And this is the first point of that end-to-end communication. My computer generates via the operating system, the protocols built into the operating system. We call that the networking stack, and it generates data to send out over the network. Well, it actually starts right here. It starts the network adapter locally, and then that's when we put it out on the electrical medium, and it's got to go to other devices within our networks.
All right, now, Wes, from that NIC, when we start talking about networking, right, we're going to have to put it into some type of connectivity device. One of the earliest ones was a hub, right?
It was, and in the earlier days we were using hubs because they provided plug and play capabilities, and it was an easy way to add multiple devices to your networks. Well, I don't actually have a hub today, and the reason is they're more of a legacy device. And what I mean by that is when you would plug into one of the ports on the hub. All right, so for instance, if we take an overhead view, this isn't a hub, but it would look a lot like this. It might be smaller in size, but when I plug into the hub from the network adapter, when the communication comes out of the network adapter and went into the hub, it would just repeat the signal across all the other ports. So the more devices you connected into one of the hubs, the more congestion you would get within this type of networking device, because every time a signal goes in, broadcast out all other ports. Another signal goes into another port, broadcast out all other ports. So it was okay for very, very, very small environments. I mean, even small businesses wouldn't be able to use it because of the contention that it brought. So the hubs are more of a legacy thing, but we put them in here just for the sake of completeness, because you might still see them used for other purposes today, but we typically do not use them because of the performance degradation that we get when we use them.
Yeah, it's interesting about the hubs because they are all hardware. There's nothing that actually tells the traffic that comes in to go out one port or another. But we do have switches that have really kind of replaced hubs.
They really have, because at this point now, it's not just plug and play with no configuration. Well, maybe it is, maybe it isn't. But the big thing is now we can use things like MAC addresses. We can start to use addressing protocols, and the connectivity device can start to make decisions on where to send the traffic. And that's where we get various switches. Now, there are a couple of different types of switches that I want you to be aware of. If we take a close-up view here, this is what is known as an unmanaged switch. Now, I will tell you, I said plug and play for the hub, but technically this is kind of like plug and play too, because it's unmanaged, and when I power this on and I plug a device in, it has the logic built into the circuitry that says, oh, okay, if I send in information in this port, I can see that it's supposed to go to the computer that is connected to this port, and now all these other ports don't have to have that contention like we did in the earlier days of the hub. So this is technically a plug-and-play type technology, but remember that it does have logic, and the switches can actually make decisions on where to send the information, and it helps to alleviate some of the contention that we had using the earlier hubs. Now, I do want you to understand that these type of managed switches, they are limited in their capabilities. We typically use something like this big switch right here in enterprise networks. This is a Cisco-based switch, and this is what's known as a managed switch. Now, I would be remiss if I did not bring Ronnie into this conversation. Ronnie, would you mind telling us a little bit about this managed switch? Because I know this is your world. This is where you live.
Yeah, when we start talking about the differences between managed and unmanaged switches, a managed switch allows us to go in and configure, if we choose to, each and every individual port to do something a little bit different as we want to. Most of the switches today even allow us to logically divide that switch up into smaller switches that we also call VLANs. That's going to be very important for businesses that can afford to buy one switch but really need, let's say, 3 physical switches. So that's not the only thing that they can do, and there's plenty of different functions with them today, and they can even take on, of course, even routing capabilities today as well. So Wes, speaking of that idea, right, that we actually have switches in that way, they can actually go beyond just providing paths for data to actually go across. They can even provide power too, right?
They sure can, and that's through a technology that we call Power over Ethernet. All right, Power over Ethernet is a technology that, like Ronnie said, that you can actually inject power into the Ethernet cable, and this is very good for devices that do not have access to an AC outlet to power them via an AC adapter. So we can bring the power to things like IP cams, voice over IP phones. This little access point that I've got right here, if we take a close-up look, you can actually see the little PoE right there in the middle. Now, I want you full transparency on this one. This is what's known as passive PoE, and it's saying that, hey, if you've got PoE on your network, we can pass it through this port, and it won't fry the port. There are some PoE, Power over Ethernet standards, that I want you to be aware of. I want you to know as well as some of the components, right? So if your switch doesn't support the PoE standard, you can get an injector and it will inject the power into the switch. The switch could have it built into it. Some of the standards that I want you to be aware of are the first PoE, that would would provide what is 15.4 watts of power. The PoE Plus, the first rendition of it, that would produce 30 watts of power, and I want you to be aware of that. But then they got in and they went to PoE++, and there was what's known as Type 3, and that was an 60-watt capability, right? Increasing the amount of power that could be over that sent across those lines. And then finally, there was the Type 4 PoE++, and that gave you up to 100 watts of power out of those ports. If you're in a certification endeavor, I would know some of those statistics. If you're supporting this from a technician standpoint, it is important to match the statistics, or the standards, I should say, up with whatever the specifications of the technology that you're implementing.
All right, Wes, I see that thing with the antennas over there. Can you help us out with that? It looks almost like an access point, but it also looks like a TV antenna.
It certainly does. This is what's known as a wireless access point. An access point essentially is a wired device that gives you your wireless devices access to your wired network. All right, our wired network is typically through our switches, right? And that allows us to communicate across our local networks, but we need to add wireless devices. And this wireless access point would do that. I can bring this up on our networks, and then all of our mobile devices, our tablets, if you will, other wireless devices can actually connect through this access point back to the wired network.
Yeah, and a lot of times, especially for the home use, right, those actually are multi-function devices that have more than just the access point to them. But speaking of that, now that we've talked about hubs and switches, we need to talk about routers, right?
Most definitely. So what we're doing is we're getting to the edge of our networks. Local area network communications are handled by switches, but one of the things a switch is limited to is it's only aware of the devices that are directly connected to the ports that we essentially see across the switch interface. Now, if I want to get communications to other remote networks, that's where the router is going to come into play. Now, the router here is another one of these big boxes that we see down here, or could be built into a multi-functioning device like Ronnie was saying, where the routing functionality is built in. The switch would connect into the router, and the router connects to your ISP and allows you to send communications off of your local area network. So you can see that in the chain that we're building here, we're working closer and closer to the edge of our network. So the routers work on things like IP addresses and allow us to communicate across networks that we are no longer, or we're not directly connected to. And that's one of the beauty of routers, is they allow us to communicate across the internet today.
Yeah, we can also see not only are there routers, though, but you might also, of course, hear about the idea of firewalls, too, right?
Yes, and Ronnie, that would be the next one in our chain. So this here is a router, or this here is a firewall box. And what's interesting is it doesn't really look like much. But if we look at it closely and we look at the ports here, we have a couple of ports. We've got a port for our LAN side interface, and we've got a port for our WAN interface as well. And this would sit outside of your router, in between your ISP's connectivity device. And what it does is the physical network or hardware-based firewall screens all of the traffic coming in and out of your network and comparing it against a set of rules, and it either allows or denies the traffic, and it's a way that we try to increase the security of our networks by implementing one of these network-based firewalls.
Yeah, when it comes down to that, right when we start talking about the edge, most of the time people are confused by that. What do we mean by the edge?
Sure, the edge. Okay, so when we talk about the edge network, the edge of your network, what I'm talking about is, think of it as abstractly, logically, right? It doesn't necessarily mean physically it's sitting in the building on the edge, teetering off the side to to some unknown location. When we talk about it, we talk about logically. We have our local area networks that are within our buildings, but then we need to communicate out of our building and go out over to the internet. Well, that edge point between our internal networks and the networks that are typically like ISPs, the router sits right there, acting like a gateway to remote networks. So it is important that we are aware of that.
Yeah, so with that idea of that modem that we're talking about, right? Where else do we go from there?
Well, sure. So this is one of the last stops, if you will, in the chain from the network adapter out to the internet. And what I have here is a modem. If we could take an overhead view of this, you can see this is an AT&T modem, and it's got a series of ports. And what I like about this, remember Ronnie said the multi-functioning device? Well, this is actually an example of a multi-functioning device because it's actually got a switch built right into it. But what I'd like to show you is a closer look of the ports that are on the back. These are important, right? Because what we see here is we've got our LAN communication. No, these are our phone lines here. This is our LAN communication, and this is our cable side, our cable line, right? So this is a cable modem. It's also a dial-up modem, but even cooler, it's also a DSL modem, if we could see right there, digital subscriber line, as well as something known as an optical network terminal. All right, an ONT. So what is an ONT? Well, an ONT essentially is a fiber optic connection, a residential fiber optic connection to a fiber optic network provider, something like Fios, if you will. So this is what's made us really from the network adapter all the way out to the ISP's device that allows us to communicate off of our networks. One of the last couple of things that I'd like to mention, Ronnie, here that I haven't mentioned yet is they talk about networking hardware. Remember, we're not just talking about networking devices, we're also talking about the physical hardware. And one of the things they mention is a patch panel. And if we take an overhead view, a patch panel really is nothing more than a series of ports. All right, we take that closer look right there, and what you'll see on the back of it is this is a way that we can hardwire our twisted pair cabling in our server closet when you have something like structured cabling. And then we can connect a pair of drops just by moving the patch cables between ports. So it's another part of your networking hardware that I want you to be aware of and be able to identify. These are some important hardware concepts that you should be able to identify.
Yeah, with the patch panel, it actually kind of, most people that haven't seen it before or understand, what we're actually trying to do is bring all of those different wires that may be spread across your entire building and have one location that we can plug our networking equipment into, right? The switch that you see right there in front of Wes, it's only in one location, but it has to spread throughout the entire building. So instead of actually running an individual wire to the other end of the building, what we do is run everything to that patch panel, and then we can run shorter, what we call, of course, patch cables directly into the switch to allow the switching to happen. So that's actually important as well as we try and logically figure all this stuff out too. Now, Wes, there is one more item that you do have on our list here. This one is probably the more complex of the ones that we're talking about.
It really is. That's something known as SDN, or software-defined networking, right? These are physical devices that require configuration on an individual device level. Wouldn't it be nice that we could throw a logical, if you will, blanket over these? Don't do that, you'll overheat them. But if we could throw a blanket over and abstract all this hardware, and we could use software and programming language, and we could programmatically control all of these devices and control them in a way that allows us to build the network through software, again using code in order to configure it. It is a very important technology that we find in endeavors like the cloud today. These are some of the networking pieces of hardware that I want you to be able to identify, so that if you're in a certification exam, you're going to be doing good. And if you're in a support role, you're going to be doing well as well.
Thank you for watching IT Pro TV.
How many different wireless protocols do you know? It probably is not as many as this guy knows. Find out what I mean next.
You're watching IT Pro TV.
Wireless. I normally just think about Wi-Fi when I hear about wireless, but Mr. Wes Bryan assures me there's more to it than that, and so we need to find out. Wes, what are we talking about when we're not just talking about Wi-Fi?
That's right. We're going to be talking about numerous wireless protocols that we need to be aware of, because like Ronnie, myself too, when I first got into the industry, I thought wireless, well, we got to be talking about Wi-Fi. It's interesting because that only makes up a small subset of a larger umbrella topic that we need to talk about. So we're going to be talking about a variety of wireless protocols.
Sounds like a lot. Let's go ahead and head on over to the bench.
All right, everyone, come on over here at the bench. And full disclosure here, we've got a couple of programs that we're going to use really to drive this conversation. One, I have a wireless access point here that we're going to enter the configuration interface, and we're going to talk about what we see here. And another one is going to be a Wi-Fi analyzer so that we can really drive this discussion. Now, it's important to be able to have the conversations that I'm having with you all today, whether you're doing this for a certification endeavor or you're doing it for a support endeavor. Let me show you what I mean. So I'm connected to the wireless interface, if you will, or the web interface, I should say, of this wireless access point right here. And I pulled up the wireless settings page, and I want you to see that we have a set of frequencies. Now, this is important. And before we go any farther, I want you to know that in being able to identify various technologies, you have to know the frequencies because they also have some associated channels with them. And this is important. And it doesn't matter, like I said, whether you're going for certification. If you're going for certification, you need to know some of the specifications. But let me show you why it's also important in a help desk or a support desk role as well. If I zoom in here to this wireless access point, you will see that we have two different frequencies. We got the 2.4 gigahertz spectrum and we've got the 5 gigahertz spectrum. Now the question is, if you weren't in a certification endeavor, would you be able to support these? Would you be able to tell me what the channels are that we have available for these different frequencies? And if the answer is no, then you probably need to do a little bit more research and be able to identify that, and that's why we're having this conversation. Now, one of the ways that we could kind of see what channels we have for the different frequencies is through an application, that Wi-Fi analyzer that I opened up before the show started. Now, when we look at this, one of the things that you're going to see, the very first thing, and it's kind of hard to see, so let me zoom in. I want you to know that we're looking at the 2.4 gigahertz spectrum. Now, the 2.4 gigahertz spectrum is the most popular one that we have out there today as far as being so widely used. And because it's so widely used, it also has a lot of congestion with it. Just basically, I want you to know there are 11 channels, but for a certification endeavor, what it's really important to know is that out of these 11 channels, one thing I want you to focus on is that we have 3 channels, and you can kind of tell this by these hills here, that do not overlap, and that's 1, 6, and all the way out here 11. And we don't have any access point broadcasting a signal on 11. Why is that important? Notice some of the in-between channels. Notice how their signal overlaps with adjacent channels. That can cause performance problems. So remember that we have those 11 channels, but 1, 6, and 11 are the ones that you want to set your access point on if you have other access points within your network or within the proximity of your network. A lot of times, ladies and gentlemen, for a non-certification endeavor, you turn this to auto and you let the access point take care of it. One of the last things I want to kind of touch on when it comes to the frequencies is if I change over to the 5 gigahertz network, and let me see here, and that is down right here. All right, I could switch over to the 5 gigahertz network, and I want you to notice just right off the top, right? You see that, Ronnie, how these channel numbers just completely change? Well, that's because 5 gigahertz uses non-overlapping channels. There's 23 channels. You don't have to know each one of those channels. That's beyond the scope of this exam. But the big thing here is to know that the 5 gigahertz, because we have these non-overlapping channels, it's not as widely used. Now, it will become widely used because a lot of your modern technologies are using it today. So, the difference between the 2.4 gigahertz and the 5 gigahertz spectrum, 2.4 gigahertz, we have to remember 1, 6, and 11. With the 5 gigahertz spectrum, you don't have to worry about that overlap because of the fact that every one of these channels are non-overlapping. Be able to identify the frequencies and the channels associated with them so that you can support this technology.
Now, these aren't just put out there because there actually are going to be radio frequency waves. We tend to have different standards, right?
That's right, we do. And Ronnie, I can actually give you all a show of that right here. So for instance, I'm connected back to this wireless access point currently right now, and you can see this number 802.11. We'll talk just briefly what that letter designation means, but more specifically, I want you to focus on the 802.11. So what is 802.11? So 802.11 is a body of standards that's developed by the Institute for Electrical and Electronic Engineers, the IEEE. They basically promote standardized wireless communications under that 802.11 body of work. Now, There's a variety of the 802.11 standards, and we need you to be able to identify them. So follow me on over here, and I've got a little chart out here, and hopefully this is going to help you to make a little bit more sense of this. This is the time to make some flashcards if you're in certification endeavors. Take some notes if you're in a support endeavor, right? We have a series of attributes I want you to be aware of. We have the IEEE standard over here and the variety of the 802 standards that are available. We'll talk about 802.11 standards. We also have what's known as the Wi-Fi Alliance. This is a consortium of wireless manufacturers that also promote their own naming designations. I'll get to that just in a second. Notice that we have a series of frequencies that are available. For you that are studying for certifications and supporting this technology, these frequencies matter because it tells us which one of these are potentially interoperable, right? And that could be a gotcha if you're sitting a certification exam. You can also see some of the speeds. For instance, earlier legacy protocols would be at 54 megs, 11 and 54 megs, but then when we get to 802.11n, the one that you've seen on the access point, now we jump up because of the technology progresses to 600 megs. We get into AC and AX, if you will, and we now get to 7 and 10 gigs. Now, I want you to keep in mind that these are the theoretical speeds. It does not mean that you're actually going to get these speeds because of all the things that can slow down wireless communications. But I do want you to be aware of the chart. Make some flashcards, if you will, and it'll help you to support the technology. Now, you're probably asking yourself, well, what's this right here? Well, starting with 802.11 AC, the Wi-Fi Alliance said, hey, all these numbers are confusing to the average person. And if you're like me, the average person, they were confusing as heck to me as well. So they said, how about we get a marketing naming convention that maybe makes a little more sense to the public? And that's when they came out with Wi-Fi 5 and Wi-Fi 6. That's what they call it versus the IEEE's official standardization. Wi-Fi 4 is just a retro name. They said, well, we already have N out there, so this is called 5 and 6. Let's just backwards name Wi-Fi 4. So if you see Wi-Fi 4, that's what they're talking about. Same thing down here. Again, take the time to do the work and get these under your belt. I can quote them. I know that because I've been supporting the technology for a long time, but I know you can do it as well, just putting a little bit of effort. So those are the 802.11 standards. It is one of those things that, well, it's not always the funnest stuff, right? We like to use the technologies. I don't know about you. I like to get into the technology. I like to actually use it. But sometimes, just like if you're learning a new language, you have to learn some of the specifications behind it.
Yeah, so when we start taking a look at that, that's probably by far one of the most popular technologies because it's been out there so long. But another technology that we want to talk about in wireless is going to be the idea of Bluetooth here. So share with us about that.
That's right, Bluetooth. Bluetooth is a very, very popular protocol because the goal is ease of use. It doesn't always work that way, but the goal is ease of use. Bluetooth is also one of those technologies that operates in that 2.4 gigahertz spectrum. And this is one of those technologies that has about a 10-meter range, if you will. So it doesn't go out that far, about 30 feet or so. And what your Bluetooth communication devices do is they go through a pairing process. First, they're put into a discovery phase where they're broadcasting their name so that other Bluetooth-enabled devices can find them. When these two devices try to connect, they go through a pairing process, and once the pairing process is done, then you can utilize the communications between these devices. Now, as far as Bluetooth specifications, if you're an exam endeavor, one of the things I want you to remember is that some of the later Bluetooth technologies were really focused on IoT devices. So in the earlier days of Bluetooth, because of Bluetooth being turned on and always trying to discover other devices out there, it would drain your battery pretty bad. It was right around Bluetooth 4.0 that they introduced Bluetooth plus LE, which is called low energy. And that means that those standards and after are now less power hungry. In fact, so much so when the marketers came out and they were saying, new Bluetooth technology is coming out, you can power your Bluetooth radio on a battery that's less than the size of a dime and it's going to last 10 years. Whether that's true or not, I don't know. That's maybe good marketing, but the point is that it does reduce the power consumption, which is why you're finding it more and more in these devices that don't have big battery lives, and it makes it a lot more efficient for a communication technology.
Yeah, so when we start talking about the idea, right, between just both of those, Wi-Fi, we tend to see, of course, things like our cell phones and tablets and even laptops a lot of times that those get on that. But what about Bluetooth? What do we tend to use with those?
Bluetooth? Well, man, I tell you, you can do all kinds of things with Bluetooth. You can connect to things like, for instance, I know I use it for speakers. So I know I use it for things like earbuds, if
Right.
you will. I use it also too. Sometimes you have file transfer mechanisms that'll allow you to transfer over Bluetooth rather than going over your Wi-Fi, and that's also on mobile devices as well. So a lot of accessories can be connected to your laptop. If your computer has your desktop, I should say, has a Bluetooth adapter in it, it can do it as well. Your mobile devices. So a very versatile type protocol that can be used to connect accessories and other types of devices across the computing environment.
All right, so Wes, we need to move on and talk about near field communication here. Now, according to what I see, it says that it's like 0 to 2 centimeters. What use is that?
That's
That's
right.
like
Not much,
less
right?
than an inch.
That's right, not much, right? Actually, it's a very, very important technology, and it's become very, very popular in mobile devices for things like contactless payment systems. If you've ever done an Apple Pay, right? Notice how close you have to get your phone or your iOS device to that point of sale system and touch it. Well, that's the centimeters. It's almost touching it, right? That's why I say 0, because once you're touching it, well, you're going to make a communication. All right. The other things that we use things like near field communication for, have you ever had to upgrade a phone and you have an old phone and it says, hey, just put your phones close to each other and we'll go ahead and we'll migrate your data to the new phone. Let's use an NFC to do that. Near field communication is a point-to-point contact type connection, if you will, that runs over 13.56 megahertz. We use it for things like asset tracking, contactless payment, proximity cards. It's another very good technology that you can use to transfer information.
Now, that sounds similar to something else for us here. Is RFID similar to this?
You know, they really are similar, Ronnie, when you think about the technology and what they're doing. RFID, radio frequency interference, it's another one of those technologies that one of the things I say, here's one of the stark differences, right, is the distance. All right, when we talk about near field communication, that is a wireless communication that's you have to be very close. Radio frequency identifications, they use close to the same technology. They can have two different types of devices. Let me talk about the components, and then I can talk a little bit about the distance, right? The main components are 3 components. A tag, and the tag is a container that digitizes and stores information. You have a reader that reads that information out of the tag, and then you've got an antenna associated with the wireless communication. Now, one of the things I said is that it allows farther distances. You have unpowered tags, and unpowered tags have a distance that is as close to near field communication, or maybe 10, 20 feet max. You have powered tags, and if you have a powered tag, you can send distances up to 100 meters, right? 100 meters, now we're talking about Wi-Fi levels, right? That's 328 feet, but it does require a powered tag. So near field communication, RFID, really close. Really, the thing I want you to keep in mind about the two is one travels a farther distance, one is a very short range distance.
All right, now our particular subject here, which I think I wasn't sure, long range fixed wireless. What is that about?
That's another thing that's trying to overcome some of the distance limitations of Wi-Fi, Ronnie. So Wi-Fi networks, I didn't quote many of the distances because so many things affect wireless communication signals that can severely reduce the distance. All right, so a lot of times what you'll see is the higher the power, the shorter the distance. The shorter the power, the greater the distance, right? That's some of the trade-offs, right? Well, Wi-Fi is just going to be restrictive in distance anyways, right? 160 feet, maybe farther indoors, maybe a little bit farther outdoors, if you will, if you're close to the antenna. Well, what if you need a wireless communication up to 1 kilometer away? Well, you're not going to be able to use Wi-Fi. And that's where something like long-range fixed wireless comes in. This is where you have providers that use licensed and unlicensed bands, and they basically get to the ability to extend the reach of that wireless communication beyond the limitations of Wi-Fi. And again, sometimes up to 100 meters. So we're talking about a 328 feet distance communication. So why would that work really good? Well, if you need a line of sight communication from one building to the next, and your building is just outside that Wi-Fi range, well, guess what? You can't use Wi-Fi to communicate with your networks between buildings. but you could use something like a long-range fixed wireless. These are some of the wireless protocols that I would be able to explain if you're going to sit a certification exam. But as I've shown you, if you can't understand the technologies, then you can't support it. So also be able to identify these technologies if you're in that help desk role, and you'll be successful.
Thank you for watching IT Pro TV.
There are plenty of networking services that you as an IT professional need to know about, but what are networked hosts? Find out more next.
You're watching IT Pro TV.
Welcome to IT Pro TV's A Plus show. We are actually diving into this realm of different services that we'll actually see in networking, but also a new terminology that I'm not as familiar with, networked hosts. Wes, what are we talking about today?
You know, it is a very generic term, and it's used because we have a variety of devices that are connected to our networks that are providing services. A lot of times we really categorize these under servers, but interestingly enough, that in today's day and age, it isn't only servers that are providing services, roles, and functionality. It's a variety of devices, and that's what we're going to help you to identify in this episode.
All right, well, let's get started. Head on over to the bench.
All right, ladies and gentlemen, come on over here, and we're going to get started here, and we're going to talk about servers first, because, you know, the term servers is a little bit more recognizable than something generically like network hosts, right? That is more of an umbrella term that our servers fall under. And we have a few different types of servers, and one of the very first types of servers that I want to talk about and the service that it provides is what's known as a directory services server. Directory databases, these are the ways that we can store all of the objects that are in enterprise level networks. And I can show you here one of the common ones that we have today, one of the most popular ones in an enterprise level environment is what is known as Active Directory directory services. Active Directory Directory Services is a LDAP compliant directory service that allows us to create and store users. We can store computers. We can store all kinds of various objects, and scalable to a very, very large, the enterprise networks, if you will. So that's one of our very first services, if you will, amongst our network hosts that we need to talk about. It's one of the more important ones. It also forms what's known as an authentication server. It isn't the only type of authentication server, but Active Directory has multiple functionalities, and one of those is to be able to authenticate the users and computers that are connected to the network.
Now, Wes, if we're really just diving into this for the first time, where do we tend to find these types of directory services?
Oh, that's great question, Ronnie. You typically find these on enterprise networks, right? Unlike smaller networks, SOHO networks, small office, home office networks, they're typically 10 computers or less, right? They can have various mobile devices, but computer-wise, they're typically 10 or less. If you need more than 10, then Microsoft recommends you get what's known as an Active Directory domain and join the corporate or enterprise world.
Yeah, it actually gives us that centralized database that now we can actually say all authentication goes through that. But that's not the only type of server that we actually do have. So let's talk about mail servers for a moment as well. If there's anything that will stop a company, right, is if email stops here. So help us understand this a little bit better.
That's right. So we have a series of mail servers that we need to be aware of, right? What are we talking about when we say a mail server? Well, we're talking about sending electronic mail, abbreviated email. And like Ronnie said, it's one of the lifebloods of an organization's outbound communications. There are a few different roles that we need to be aware of. The very first one is what's going to be known as SMTP. That SMTP server, that's outbound communication. We also have another one, and that one is an oldie but goodie as well, and that's a POP3 server, the Post Office Protocol version 3 server, and that's for retrieving email, inbound email. And one of the more common ones that we use today, and you're probably using this if you have any kind of Gmail account, is what's known as an IMAP server, right? That's the Internet Mail Access Protocol. So 3 different servers, right? 3 different server types, if you will, but they're all fall under that email or mail server generically.
Now, when I first started working for a business, I was kind of surprised that we actually had to set all these things up. Actually, manually, some technician had to come over and actually go ahead and enter this stuff in. But as technology developed, a lot of this was as soon as I logged into my user account, it was set up for me. I didn't even have to touch anything, and I could get my email. It's actually pretty neat to actually get started there.
It most definitely is. Now, one of the things that's interesting, Ronnie, that we need to mention is another type of server that we really rely on for just finding about just any device within our networks and really across the backbone of the internet, right? And that's what's known as a DNS server, right? We are not shy of acronyms here within our episodes. DNS, if you will, is the domain name system, and I can actually show you kind of what that's a little bit about. DNS, if you will, it holds records for the computers that are within your network, if you will. It keeps track of it in a database, right? So the DNS server is a way that we can store all the records for the devices that are within the computers, if you will, that are within our networks. Generically speaking, remember that a DNS server, what it does is it provides us name resolution, taking those user-friendly, fully qualified domain names and allowing us to map them to IP addresses. A very important service, and one that you should have not only a familiarity with, but you should be able to work with and troubleshoot if you're getting into the IT industry.
Yeah, this is something, even though it feels like we're glossing over it a little bit, we are going to dive a little bit more into that, aren't we?
Oh, absolutely. Yeah. So the next one that we have to kind of look at is what's known as the DHCP server. And when we look at a DHCP server, the DHCP server allows us to dynamically push out configuration settings. And one of the most popular things that DHCP, or the Dynamic Host Configuration Protocol server, does is it allows us to distribute, if you will, IP addresses to various clients within our network. So give you an example of this. When we talk about a DHCP server, a DHCP server is set up with what's known as a scope, if you will. Let me go ahead and bring up the DHCP server interface here. And within the DHCP scope, it's a range of IPv4, IPv6 addresses that we can lease out to clients that join our networks, and they ask, hey, I need an IP address out there. Is there a server out there on that network that's got one? Our DHCP servers respond and allows us the ability to ease the burden of manually assigning IP addresses across large enterprises, even small enterprises, and makes it our lives as administrators a little bit easier when it comes to IP addressing.
Yeah, this is actually one of those services that we really don't even think about, right? That's working in the background for us, that allows for easier management of anything that's happening on our networks by assigning those IP addresses and keeping track of them. Because if we end up with duplicate IP addresses, they're really going to actually conflict, and we're going to actually see a lot of error messages as well. Now, along with that, Wes, we also have file servers that we need to talk about.
We do, and one of the great things, when we look at something like we're using Windows Server 2022 here, and one of the great things is by default, a lot of these servers come with some form of file and storage services already ready to go for us, right? And we can have volumes, we can add disks, if you will, we can aggregate more than one hard drive or storage device together and create a larger, what's known as a storage pool. Keep in mind that file servers in general, you might hear them generically say file share service, right? This allows us to put files and folders out on the network and then have clients connect to them and pull those files over the networks. We have some of the traditional ones like FTP servers. We have NFS servers, network file systems, if you're not in the Windows environment. If you're in the Windows environment, we have things like SMB, the server message block, that allows us to connect over to networks and gain access to the shared file resources across the network.
Yeah, so that actually is one more important things too, because we tend to, of course, generate a ton of different documents, files, whatever we might need. We want to, of course, make sure that they're saved someplace that could be easily accessible from wherever you're actually going to be. Now, the other part of that lifeblood that we were talking about, Wes, for a moment, we talked about email, but is the idea of printing. If somebody cannot print to the actual printer that's right there, people begin to get a little bit more upset. So tell us a little bit more about print servers.
Sure. Now, a print server is interesting because if you haven't seen a server before, servers can be very, very large and heavy devices that are typically in data centers. They can be smaller tower-based in smaller businesses, but that's what we tend to think of when we think of a server, a very, very powerful computer. But I want you to understand that print servers can be nothing more than the size of an average Apple TV box or a Roku box, right? Because it's the service that they're providing. I have the print management service actually set up on this server here because our server operating systems here can allow us to do print management as well. And one of the things things that you can see here is that with a print management functionality where you have a print server, we can load up drivers. We can see the printers that we have already within our networks. I can do things like open the print queue, and if there were print jobs in here, I could modify those print queues. I could turn around and I could deploy these printers too, all from a centralized location. Now, if you are in a business that maybe you only have one printer, you might not need to go through all of this. But if you're in an enterprise level corporation where maybe you have multiple rooms or multiple floors within a building, and you have multiple printers that you need to be able to service, a centralized location to do that, like a print server, is the way to go.
Yeah, print servers are pretty much one of the more important things that affect the end user immediately. So if you actually do get calls, a lot of times it is because people will not be able to print. So it's something handy that you actually want to make sure that you do understand that concept of too.
Mm-hmm.
Now, Wes, here's a concept that's a little bit older, but it is something that people need to understand. Where in the world do we tend to find syslog servers?
Well, a syslog server, it's short for system logs, and syslog servers are typically something that we have inside of Nix-based systems. Now, Nix, I mean Unix and Linux-based systems, because in those systems they have what's known as a syslog service functionality, daemon, if you will, that generates the system logs and stores them locally. One of the big things about these services that the network hosts are providing, you've heard Ronnie mention it, you've heard myself mention it, is it allows that centralized management, and that's what we want in large environments. So what we can do is we can set up a syslog server, and all your Unix and Linux-based systems can actually report over to that syslog server, and then an administrator of those systems can look in a centralized location to check all of the variety of system logs, if you will, across multiple devices in that single location.
Yeah, there's no doubt that all of these are actually very important, even though we don't tend to see how they work. We do actually end up seeing that they are working for us is what we want. Now, the front-facing side of a lot of businesses, though, are web servers. Help us out here, too.
Sure. So web servers, if you've been to our website at IT Pro TV and ACI Learning, you've come in contact with a web server. For instance, I've got the ACI Learning web page up here, and what is actually going on here? Well, my browser actually generated a request and sent it out over the HTTP protocol, the Hypertext Transport Protocol, and said, hey, I want to connect and see that web page. Well, my browser connected to the ACI's web server, ACI Learning's web server, and pulled down that HTML and generated the web page. And that's what a web server it does for us, amongst many other things. It allows us to browse and view web pages when we connect to them.
Yeah, all these are actually good services that we should be fairly familiar with as an A+ technician. And of course, as you continue to advance your career, you actually see that you need to dive a little bit deeper into this as well. Now, the other things that we can begin to talk about here are things like internet appliances. So Wes, what do we mean by that? What's an internet appliance?
So internet appliances, they can be very, very expensive. They can be a little bit generic too, but usually what we see in these devices is very, very expensive security-based devices. UTM, if you will, it's just short for the Unified Threat Management. That's an example of an internet appliance. Now, understand that it's not a server, and that's why we use the term networked host, because it's connected to our networks. Now, we're going to go shopping with Ronnie's credit card here, and as you can see that some of these devices get very, very expensive. These are something that is used within enterprise networks. Here you go, you got a UTM device and it's about $200,000, right? So they get very expensive, but the concept is really what's important here. It takes multiple security functionalities and integrates it into a single component that you can manage in a centralized fashion, thereby making it a lot easier for us to manage some of our security infrastructure. Other ones that we have too, we have things like load balancers, and what a load balancer is, it's a way that we can distribute resource requests from some of those servers in our networks, if you will. We can take a load balancer, and when a client requests, we can spread that workload across multiple servers and essentially even out that workload, distribute it evenly, so that if one server is getting a little bit too overburdened, we can send those requests to multiple servers, making the performance and the user experience a lot better on the back end. So load balancers allow us to distribute a workload across multiple endpoints, or in this case, typically things like, for instance, servers. Now, speaking of web servers, right, one of the things that also kind of falls within the realm of a web server is what's known as a proxy server. Proxy servers are very good because what you can do is you can set a proxy server, if you will, like a web server, in between a web server and the client. When a client makes a request, the client doesn't actually go directly to the website like you just seen me with ACI Learning. What it does is it actually goes to a proxy, and then the administrator can centralize or can centrally manage what and who can gain access outbound to the internet. That's a proxy. A proxy sits in between a client's browser and the web server and makes requests on behalf of the client. The benefit for your administrators is they can control who can gain access to what through the proxy itself. So these are some of the internet appliances that I would be aware of, whether you're in a certification exam endeavor or even in a support role.
Yeah. So along with that, right, the very fact is like proxy servers, we tend to see them in certain contexts a lot more often than every context.
Sure.
So things like schools, we tend to see them because we want all the students to actually go to a proxy server and not directly out to the internet.
That's right.
Too.
That's right.
Now, the other systems that we want to talk about here, and this may, you'll have to tell me, Wes, is a SCADA system?
I've heard
that
it said both SCADA and SCADA. I've heard of both.
Is that a networked?
That is a giant, I would say, massive collection of components, right? Okay. SCADA systems almost form their own, typically in isolated networks, and they are connected to, routable networks. But these are essentially, think of your control systems, your industrial control systems. Think of things like power plants, if you will, right? Large infrastructure that uses a variety of components to control different aspects like water pressure, if you will, power elements. These are large systems. And the SCADA, if you will, is the supervisory control and data acquisition. And what we need to do is we need to figure out the information from a variety of these sensors, if you will, remote telemetry units that are just sending wireless information and collecting it in a centralized location. And it allows us to view that information. This is typically done in these large systems that run things like power grids, if you will, not just power plants, water systems as well. Think of those type of utility services. These are very large systems, and you might run into them.
Yeah, a lot of times where we tend to see those are things that actually require like what you were talking about, the idea of the control of shutting off valves, turning them on, of doing that and ensuring that actually done across the entirety of a building or actually in the entire site if we wanted to.
Sure.
So they're programmable. They actually allow us to do that as well. Now, the other thing that you actually have here on our list is IoT. If there's a very vague term, it is the term IoT. Somebody beginning to kind of dive in A+, this may be a little bit questionable for them. They might have heard the term a lot, but may not know exactly what that means. Help us out here.
Sure. Internet of Things is a variety of devices that basically connect to the internet. You've probably seen some of these before. In fact, let me give you an example here. I've actually got pulled up on our screen one of the more common IoT type devices that we see today. For instance, like a Raspberry Pi, you might hear things like Arduinos. These are essentially boards that can be completely self-sufficient. A lot of times are very low powered devices, and they form networks together that mesh together and communicate. If you've seen things like home automation systems, that is an example, a big example, if you will, of IoT devices. These devices are numbering in the millions and millions, if not billions today. It is a large market of IoT devices. If you want your refrigerator connected to a network, that now becomes an IoT type device. If you look at, like I said, these Raspberries, if you look at Arduino boards, these various printed circuit boards that have basically small computers built into them. So the IoT devices are just a variety of devices, small devices that can be connected to our networks today.
Yeah, it's difficult for somebody that may come from like old school like we did, right, where everything plugs into a computer and then that device gets access to the network or actually does that. These devices, though, can stand independent alone, don't need another computer to actually make them work and to do all those different things too. So those are some of the different considerations that we have to think about as well. All right, Wes, anything else we need to talk about in this episode?
No, just be, one of the big things here is just to be able to, again, if you're in a certification endeavor, make sure that you can explain these and you understand what these devices are and some of the services that are provided for them. And that's also going to be beneficial if you are in a support role.
Thank you for watching IT Pro TV.